So I got asked if I could talk a little bit about mathematical induction, so I'm going to do that here now. So really what induction boils down to is the idea of you have two pieces of criteria for a mathematical statement. So the first is that you have a base case that holds true. So let's just call it x. It's typically 0 or 1, but this is a true thing. And the second piece of criteria is that, okay, so if we evaluate this statement, then the next statement along is also true. And these two pieces of criteria are enough to work with all values greater than x. And what I mean by that is, let's say that there is some number bigger than x where this doesn't work. So this is y greater than x. That's false. Well, how could this work? So if we know that it's true for x, you can write y as just being x plus some number, let's call it a. So kind of trivially from our base case, so we know that this is true for sure, then x plus 1 is true, then x plus 2 is true, then x plus 3 is true, and so on, and eventually you are going to reach x plus a, where a is just some integer. So the claim that there's going to be a falsehood here is just not true, so it's kind of a proof by contradiction. So if that doesn't make sense to you, then I'm going to go for an example right now. So what we're going to look at is the sum of the mth odd numbers. So we're going to go up until 2m minus 1. So this is going to be the sum of m odds. And I'm going to claim that this is just equal to m squared. Okay, so let's first check our base case. So the sum of the first odd number, so I'm just going to choose 1. Well, it's just going to be 1. We take 1. You're not adding any more terms than that. So we know that this is true for our base case. So 1 equals 1. Now let's look at the mth case. So we're going to assume, oh no, sorry, the m plus first case. 1 plus 3 plus 5, blah blah blah, plus 2m minus 1, so that's the m minus 1 case, plus 2m plus 1. So we know from our sort of induction hypothesis that these terms here, we claimed that these are equal to m squared. So we're going to have m squared plus 2m plus 1. But notice that we can factorize this as just being m plus 1 all squared. And so our induction hypothesis is also true, because it's as if we've just replaced m here with m plus 1, and so therefore we can see that it's going to hold for all values that are bigger than 1.